Hi, this is Craig with Gertech, and I am going to walk you through the dual compressor simulation for the LogixPro simulator. So the customer in this one wanted three modes of operation. Mode A is going to be both motors, or if the usage of the motors is out of balance, it's going to decide which motor needs to run to bring them back into balance. Mode B is only motor 1 running, and mode C is only motor 2 running. Um, excuse me. Um, yeah, so that's that. So let's go ahead and start it, and we'll see how it works. So as you can see, both are running to bring the PSI up to the both of the set points. Okay, and then actually when the lower pressure set point is made, which in this case is going to be number 2 over here, when this is made, this is going to not be active anymore, and it'll turn off our pump. So to show you how the flip-flop balancing action works, I'm going to put it in mode B so that we can get our run time balance different. Alright, so while this is doing this, let's go over here and talk about the logic. So first, we have our start button. Once you push that and the stop button is not being pushed, that will fire and turn on the light. And once this light turns on for a moment, for that momentary second that this is pushed, it will activate this bit that is the light. So what this does is, the moment that this lights up, this also becomes active, which will seal in this circuit. Okay, so next we have our motor controls. So the motor controls, as I said, is mode A is it alternates, or it can use both. Mode B is motor 1 only, and mode C is motor 2 only. So here I have my I forgot to mention that I also use this bit as a running interlock. That way I don't have to create a new bit. So when the light's on, that means that we are running, and that means that the motors can run. So that's what that is here. And then over here we have our modes: mode A, mode B, and then mode C down here. So as you can see, in mode B, there's no special qualifiers. It's just the pressure one, the set point for this pressure switch to run the motor. And when the motor's running, it's going to activate the corresponding light. So same with C down here. And then in A, what's going to happen is, let's go ahead and pop it into A. So as you can see, now we got both motors running, right, because of this circuit right here, that path. Now as you can see, we are now satisfied here, so it turned off these, but because we're calling for more of motor 2, only motor 2 is running. As you can see, our display is counting down that difference from when we were in mode B and I was running only motor 1. So let's go on down and we'll talk about how I go about making this decide which motor it wants to run. So here we have our motor counters. So this is just a bit saying when motor 1 is on, in this case, and when motor 2 is on, the retentive timer on is running. So this is an RTO, and a retentive timer on. These bits are like your TONs, your time on, but instead the difference here is these need to be reset by code. They when it's de-energized, it holds that count that it has. It's not going to reset every time it loses energy or it becomes not active. like a TON. They reset. These RTOs, they keep that number until you tell it to reset. So next we use these counts up here for our motor balancing. So what we have here, and we'll look at this one because it's active. So basically what this says is if motor 1 is been used more than motor 2, then I want to activate this virtual bit that says, hey, I want to use motor 2 more. Up here we have just the opposite, but it's for motor 1. So it's saying if I've used motor 2 more, then I want to use motor 1. I'm sorry, if I've used motor 2 more than I've used motor 1, then I want to activate this bit that says, hey, I want to use motor 1 more. And we'll go back up to our motor controls. And as you can see, that's what our secondary circuit is for here. I guess you might want to switch these, but anyways, so yeah, as long as motor 1 is not running and we're getting the bit that says motor 2, I want to use motor 2 more, and the pressure switch, the number 1 pressure switch has not been made, run motor 2. And up here for motor 1, it's just the opposite. It's I want to run motor 1 more, and motor 2 is not running, and pressure switch 1 is not satisfied. Then let's run motor 1. Okay. So next we will go back down here, and so this was the bits I was just talking about. So next we have our reset counter with equal use. So what this does is it says I want to reset my retentive timers on when my motor use has gotten back to being an equal number. Okay, so I had to put in this qualifier here, this greater than, and the reason why I had to do that was because if you don't have this, as you can see, 0 is equal to 0. So when this is active, it would constantly reset the retentive timers. So it would never actually allow accumulation of retentive time. So this is just basically saying that once it gets more than 2, then we want to look for when it's equal. And that's just like a little bit of deadband to allow there to be some to allow it to get past 0 so that it can actually start. Okay, so the next thing that we do here is this is where we calculate the difference, and I'm sorry, this isn't where we calculate the difference. This is, well, it is where we calculate the difference. It's so we calculate the difference in a way to display it up here. So what we're doing here is saying that if motor 1's use is greater than motor 2, then what we're going to do is subtract motor 1 from motor 2 and send that over to this number, this bit, to save that number. Okay, and then if it down here, what we're saying is if the usage of motor 1 is less than motor 2, then what we're going to do is we're going to subtract the motor 2 from motor 1, and then we're going to move that into that integer and save that number. And then down here is where we display that number up here. Okay, so this is a TOD. This is a to display. So here's our integer number, and as you can see, this number corresponds up here. Okay, so that's the dual compressor simulation on LogixPro Simulator. Thanks for watching.